Good afternoon, friends. Last lecture we have to discuss the introduction of the synthesis of the solid. Okay, and therefore we have to start it about the second point, that is about the common reaction employed in synthesis. Okay, in this common reaction employed in synthesis, we have to discuss the inorganic material synthesis. Okay, that the some common reaction that employed for the synthesis of inorganic material means you are to following reaction, this following reaction you have to employed in the synthesis of the inorganic material means, therefore we are to synthesize the inorganic material for the following reaction. Okay, first reaction we have to discuss, that is the decomposition reaction. Second reaction we have to discuss, that is the addition reaction. Third is metathetic reaction, and fourth is other exchange reaction. Okay, therefore we have to discuss of the typical example of this reaction are as follow. Okay, therefore firstly, that is a calcium carbonate solid, it gives as calcium oxide solid plus CO2 gas. Okay, that this reaction it shows that it is a decomposition reaction. Okay, this first typical example it shows that it is a decomposition reaction, and that decomposition reaction, therefore the solid it is converted to solid plus gaseous, means that the calcium carbonate solid it therefore we are to decompose it, therefore it is formation of the calcium oxide in a solid and the carbon dioxide in a gaseous. Okay, then the silica tetrahydride gaseous is equal to, therefore in presence of the silica solid plus 2s2 gases. Okay, this is the second reaction in the decomposition of reaction, and this is the typical example of first is a example of the decomposition reaction. Okay, secondly, the YbA2CO2O6 solid plus O2 gaseous, it gives as YbA2CO3O2 solid. Okay, and then the zinc oxide solid plus Fe2O3 solid, then it is formation of the zinc Fe2O4 solid. Okay, this reaction it is says that this is a example of the addition reaction. Okay, this second typical example it is an example of the addition reaction. Okay, then third reaction is about the CO gaseous, that is a carbon monoxide in the gaseous form, then it is treated, then you have to addition of the MnO2 solid, then you have to formation of the CO2 gas and the manganese oxide solid. Okay, then the prononcium 6 then O11 solid plus 2s2 gas, it is formation of the 3pr2o3 solid plus 2s2o gases, and SiCl4 gaseous plus 2s2 gases, it gives as the silica gaseous and 4SCl gases. Okay, this is the example of this metathetic reaction. Okay, that metathetic reaction it is says that therefore you have to first starting reactants is in gaseous form, and then the MnO2 also in gaseous solid form, therefore the gaseous plus solid its additions product is about the gaseous plus solid. Okay, then the prononcium, that is a Pr6O11 solid plus 2s2 gas, that is a solid plus gas, it is formation of the solid gas. Okay, that is a 3pr2o3 solid in presence of solid state, then it is formation of 2s2o, that water vapor it is formation in the second point. Okay, then the silica tetrachloride in presence of gaseous form plus 2s2o gaseous, it is formation of silica gases. Okay, it is formation of silica gases, and that silica gases plus 4 times of the SCl in gases. Okay, this is the third reaction, and that third reaction into the third example, and that example it is of metathetic reaction. Okay, this is the example of the metathetic reaction, and the fourth reaction is about that the fourth reaction it is shows that the zinc sulfate solid plus cadmium oxide solid, it gives as cadmium sulfide plus zinc oxide sulfide. Therefore in this fourth reaction, that fourth reaction it is that other exchange reaction. Okay, that fourth reaction is a other exchange reaction, and that other exchange reaction that is about the zinc solid plus CdO solid, it gives as Cd solid plus zinc oxide solid. Okay, you have to exchange it, therefore that is exchange means what, therefore you have to first atom, that is about the zinc and cadmium. Okay, that zinc and cadmium you have to exchange in this reaction, you have to exchange in in this reaction. Therefore it is a formation of cadmium sulfide solid plus zinc oxide solid. Okay, that cadmium, it is a exchange with zinc, and zinc is a exchange with cadmium. Okay, this is the exchange reaction. Okay, then the second example in this reaction, that is about the manganese MnCl2, manganese dichloride, in presence of solid plus 2 times of HBr. Okay, therefore the Cl, that the Cl, it is a replaced with the Br, and the Br, it is a replaced with the Cl. Therefore it is a formation of the MnBr2 solid plus 2 times of HCl. Okay, this is the example of the other exchange reaction. Okay, this is all about the common employed reaction. Okay, then this nextly, that is it is also the part of the common reaction employed in the synthesis, that is about the complex reaction, it involving complex reaction, it involving more than one type of reaction are employed in the solid state of synthesis. Means you have to know about the complex reaction. Okay, complex reaction that involving more than one type of the reaction. Okay, you have to know very well known about the complex reaction. Complex reaction are involving more than one of the reaction are employed in solid state synthesis. Okay, therefore you have to you have to know about the complex into the bracket, that is this bracket, it is shows that this bracket, it is shows that you have to know about the your complex molecule, you have to enter this bracket, and therefore the charge on this bracket, that is shows the complex form. Okay, that shows the complex compound, and that complex reaction involving more than one type of reaction. Means in your complex reaction, it involving two types of the reaction, and that two types of the reaction are employed in solid state of chemistry. Means that two types of the reaction are employed in solid state synthesis. Means these two reaction, this is the one type of the reaction, and that reaction it is employed in solid state synthesis. म्हणजे तुमचं जे सॉलिड स्टेट सिंथेसिस आहे त्याच्यामध्ये या कॉम्प्लेक्स रिॲक्शनमध्ये एकपेक्षा जास्त रिॲक्शन काय असतात, इन्व्हॉल्व असतात, आणि ते एकमेकांमध्ये काय करतात, एम्प्लॉयड करतात. कशामध्ये, सॉलिड सिंथेसिसमध्ये. ओके, देन थर्डली प्रिपरेशन ऑफ द कॉम्प्लेक्स ऑक्साइड, it's common to carry out the thermal decomposition of the compound and that followed by the oxidation. Okay, therefore in this preparation of the complex oxide, okay, you have to prepare the complex oxide, and that oxide, it is a common to carry it out in thermal decomposition. Means in your thermal decomposition, therefore your complex oxide, it is prepared. Okay, and that thermal decomposition of the compound, it is followed by this oxidation. Means that thermal decomposition of the compound, it is followed by this oxidation reaction. Means therefore you have to oxidation reaction, that oxidation reaction, it is formation of the thermal decomposition of the compound, and this compound you have to use for the preparation of the complex oxide. Okay, look at this reaction, that is the 2 times of the calcium 0.5 Mn 0.5, and that the CO3 solid plus 1/2 O2 SS, it is a formation of calcium manganese trioxide. Okay, it is formation of calcium manganese trioxide solid plus 2 times of the CO2 gases. Okay, this is the reaction. That reaction, it shows that the preparation of the complex oxide and also the decomposition of the compound. Okay, therefore next is the vapor phase reaction and the liquid gas reaction yield solid product. Okay, you have to know about the vapor phase. Okay, that vapor phase reaction and the liquid gas reaction. Okay, you have to know vapor phase means it is a vapor, and that vapor phase reaction and the liquid gas reaction, it is a formation of the yield is solid product. Means therefore your vapor, it is treated with the liquid gas, and it is formation of the solid product. Okay, then next point is, in the chemical vapor transport reaction, a gaseous reagent act as a carrier to transport the solid by transferring into the vapor state. Okay, in this chemical vapor chemical vapor transport reaction means what, therefore your gaseous reagent act as a carrier transport. Means in your gaseous reagent act as a carrier transfer. Means that gaseous reagent means sometimes the different types of the gaseous reagent, and that reagent you have to use as a carrier of transport. Means carrier of transport means what, Therefore in this gaseous reagent the some chemical vapor are transferred in this reaction, and therefore this reagent it is a carrier to transport of solid, and that solid it is by the transforming into the vapor state. Okay, then for example the MgCr2O4 it cannot be readily formed by this reaction of MgO and the Cr2O3. Therefore the Cr2O3 solid it react with the O2 given as the chromium trioxide, and that chromium trioxide when they react with the magnesium oxide it giving the chromate. Magnesium oxide बरोबर treat केल्यानंतर काय भेटणार आहे chromate, and therefore the overall reaction is about the magnesium oxide solid plus Cr2O3 solid in presence of Cl2. Okay, in presence of in presence of O2, and that O2 means it is an oxidation reaction, and therefore it is formation of the MgCr2O4. Okay, MgCr2O4. Okay, look at this. Therefore this Cr it shows in the two form, therefore it is a MgCr2O4 solid. It is a formation by magnesium oxide and the dichromium trioxide. Okay, the some of the typical transport reaction that equilibrium are the zinc solid zinc sulfate in presence of the solid plus I2 it is formation of ZnI2. Okay, it is formation of ZnI2 and the half of the S2. Okay, then the TaOCl2 solid, TaOCl2 means that is a tantalum. Okay, that tantalum trichloride solid plus tantalum pentachloride in presence of TaOCl3 plus TaCl4. Okay, then the gallium arsenic solid plus HCl is gives as gallium chloride plus half of H2 plus arsenic. Okay, this is the reaction, and that reaction we have to use in the complex ion reaction, that is used in the preparation of complex oxide. Okay, then next is the transport of two substances in the opposite direction. It is a possible if the reaction have the opposite heat of reaction. Okay, therefore you have to know about the therefore this last sentence is about the typical transport reaction equilibrium. Okay, this is the transport reaction, and that transport reaction of the two substances in the opposite direction means, therefore this is the two substances and that two substances in the opposite direction. Okay, look at this. This substance is direction from this, and this substance is direction from this, and this is the two substance, and that two substance direction is in opposite direction. It is a possible, and if the reaction have opposite heat of reaction means, therefore this substance and this substance, that two substance have opposite heat of reaction. It is opposite heat of reaction means, therefore these two substances direction it is opposite direction, and therefore it is a possible, and but its reaction have opposite heat of reaction means, therefore this substance heat of reaction is greater, and this substance is rate of reaction is less, heat of reaction is less. Therefore this is the opposite heats of reaction by this opposite direction from the transport. Okay, then the next is the volatility of the product also allows its separation from other species. Thus the reaction of Cl2 gas with the solid mixture of Al2O3 and the carbonyl AlCl3 and the CO gas. Okay, therefore you have to know about the volatility of the product. Okay, you have to know about the volatility of the product. That volatility of the product it is allowed to separation from the species means, the species it is separated by the volatility means, that volatility of the product it is also allows the separation from the other species. Separation from the other species means what? Ki some species have the volatile component, therefore this volatility it is useful for volatility of the product, it is useful for to separate the volatility component from the other species. Okay, then thus the reaction of the Cl2 gas with the solid mixture of Al2O3 and the carbonyls of AlCl3 and CO gases. Okay, then next is the vapor transport method are used in the synthesis of material as exemplified by the reaction of magnesium oxide Cr2O3. Okay, therefore the vapor transport method are used in the synthesis of material. म्हणजे तुमची जी vapor, therefore your vapor transport method means that vapor it is containing some chemical component or some volatility component. That volatility component, therefore this vapor it is a transport from the other side, and therefore this method it is used in the synthesis of material, and that material it is exemplified by the reaction of the magnesium oxide and the Cr2O3. Okay, look at this reaction. That reaction is about the Cr2O3. Okay, that Cr2O3 solid plus 3 times 3 upon 2 O2 and then 2 CrO3 gases. Okay, this is the reaction. That reaction, it says that the CrO3 solid in presence of addition of the 3 by 2 O2 gases, it is formation of 2 CrO3 gases. Okay, therefore the one molecule plus one molecule, it is formation of the two molecule of the trichromide. Okay, then the second reaction, it says that the 2 CrO3 gaseous NiO solid, it gives as nickel dichromate tetraoxide. Okay, this product is formed. Okay, then the formation of the Ca2SNO4 by this reaction or the calcium oxide and the SNO2, it is facilitated by the via the formation of the gaseous SNO, which then react with the calcium oxide. Okay, you have to formation of the Ca2SNO4. Ca2SNO4, it is also the example that it is also the compound, organic compound, and that organic compound you have to form by the reaction of calcium oxide and the SNO2. Means the calcium oxide and SNO2 in presence of the heating, therefore it is formation of the Ca2SNO4, and that SNO2 is facilitated by the CO via the formation of gaseous SNO. Means gaseous SNO, therefore the CO via it is a formation, then which then react with the calcium oxide, then that CO, it is a react with the calcium oxide. Okay, then the reduction of the oxide, it is a carried out in atmosphere pure or the dilute hydrogen, or sometime in atmosphere of CO or the CO-CO2 mixture. Okay, therefore you have to know about the reduction of the oxide, that the reduction of the oxide, it is a carried out in atmosphere. Means in your reduction of the oxide, it is carried out in atmosphere, that atmosphere, it is a pure or dilute hydrogen. Okay, this is also the point in this common reaction employed in synthesis. Then the reduction of the oxide for the purpose of lowering the oxygen content is also achieved by the heating oxide in argon nitrogen by using this metal as a guitar. Okay, therefore this reduction of the oxide of the purpose of lowering the oxygen content is also achieved by the heating of oxide. Means in your argon or the nitrogen, therefore you are to heating them, and it is a heating the oxides in argon and nitrogen. Means in your argon and nitrogen, therefore oxides you have to heated them, and it is achieved the oxygen, lowering the oxygen content into these, and therefore it is using the other metals such as the guitar to remove the some of the oxygen. Means that some of the oxygen are removed from argon and nitrogen. Okay, then next is the exact control of the oxygen stoichiometry in oxides such as the Fe3O3, V2O3 is accomplished by annealing of the oxide, that is the CO-CO2 mixture of the known the fugacity, its appropriate temperature, and that thermal decomposition of the metal halide often yields the lower halide. Okay, this is all about the common reaction that employed in the inorganic material synthesis. Okay, then the soft chemistry route we have to discuss in next lecture. Okay, thank you.